Newton's laws. And Newton's first law states that an object at rest tends to stay at rest. Also that an object in motion tends to stay in motion. And Newton's second law of motion states that a net force causes an object to accelerate. And this can just be described much easier with the equation that F equals mass times acceleration.
We're going to do an example problem. The problem states that we have a 50 kilogram skier going down a 25-degree slope. In the givens, obviously she's 50 kilograms, the slope is a 25-degree angle, the coefficient of friction is 0.12. We have the distance that she's skiing is 60 meters, her initial velocity is 4 meters per second, and we're going to try to solve for the final velocity. So when approaching these problems, you want to make a free body diagram. You can use this dot, represents the skier. She has the force of gravity going down. She has acceleration this way, down the slope. She has normal force and the force of friction going the opposite.
Alright, in order to find the final velocity of the skier, we're going to need to find the acceleration of the skier. In order to do that, we're going to use Newton's second law. But before we can go there, we need to find all the forces acting on the skier. So as in the free body diagram, we have the normal force, so we're going to find the normal force. Then we're going to find the frictional force, and then we're going to solve for the components of gravity. So we're going to start out with the normal force, which we have here. And to find the normal force, we're going to use the y component of gravity, and normal force is essentially the opposite of that. So we have that done right here, equals 207.08 newtons. Now that we have the normal force, we're going to find the force of friction. The force of friction is solved for using the coefficient of friction and the normal force. So you multiply those together to get your force of friction there. It's 24.85 newtons. Now we're going to plug that into Newton's second law, so we have the sum of all the forces on top. Remember, friction is in the negative direction, divided by the mass, gives you an acceleration of 12.53 meters per second squared.
Now that we've solved for acceleration and found the value, we can plug it into a kinematic that we've learned previously. This specific kinematic is not including time because we're not given time in the problem. It goes velocity final squared equals velocity initial squared plus 2 times acceleration times the change in distance. So we have all these values right here. We're going to plug them in, take the square root because velocity final squared, and that gives us final velocity of 38.98 meters per second, and that's our final answer.